Okay, so this is going to be Introduction to Division. And here's our question to start out with. You can have some thoughts here. Okay, so our question is, what is division? What does it mean? Okay. Take a second to think about it, and if you have something to share, then please do.
Is it like taking a number and breaking it down into equal parts?
Okay, great. So you have a total, and you're breaking it down into equal parts, equal groups.
Yes.
Great. Any other thoughts on what division is?
Dividing the number into equal parts. It's pretty much just what she said.
Yeah.
It's the inverse of addition or of multiplication.
Right, and that's how the book defines it. So your first part of your homework is to read in the book about it. So what does division mean? Well, it's, yeah, you're taking a total. You can call it dividing, but sometimes we don't want to use a word as similar to the word, but you could say dividing. But what's another word for divide that I can use?
Separate.
Great word, yeah, separate. We can do equal parts, or we can do equal groups. Okay, good. So you guys have the gist of it already. In the book, they talk about the perspective with inverse of multiplication. So division is defined by missing factors. And if we say missing factors, we are automatically denoting a multiplication problem. So it's defined as defined by the missing factor in the multiplication problem. If we have, I'm going to use some letters to represent any number. A divided by B equals blank. Okay. That is defined by the missing factor in blank times B equals to A, or B times blank equals A. So it could be either one of the factors in a multiplication problem. Okay. So that's how we define that. Here are the parts of a division problem. Each of the three numbers has a name. A divided by B is equal to C. Okay. So let's see if you guys remember what these names are. What is the name of the first letter, or the first number, sorry?
Is it a minuend?
Close.
Or is that
That's one for
just in-
subtraction.
Okay.
I haven't actually mentioned these words before in this class.
Is it the dividend?
Great, dividend. The dividend, it represents the total, okay? Because you have these names you can mix up a little bit, but the dividend is the total that you are taking that you're going to divide up. Okay? So the dividend, and then this one is similar in that it also starts with a D. It starts with a D-I-V-I as well.
Is it the
The
divisor?
divisor?
Yep, good. Divisor. Oh no, there you go. Come on, iPad. Okay, yep, that's the divisor. Now the answer to a division problem, you probably know that one. Use that one a little more commonly.
The quotient.
Right, that's the quotient. Okay, so those are the parts of the division problem. You can refer to those. Here's an example. If you want to think about what 56 divided by 8 is, set that equal to blank. The dividing part is the missing factor. Think about the inverse of multiplication. And think about what number, as we think, what number do I multiply 8 by to get 56? Okay. That's what you're thinking when you see this problem. Okay. Thinking 56 divided by 8, but to find the answer, you have to think about, well, what number do I multiply by to get to 56? So you can think about it as blank times 8 equals 56, or 8 times blank equals 56. So that's the example there. It turns out that there are two types of division because of these I see here. Because if I don't know the first number in the multiplication missing factor, or I don't know the second number. And remember that even though multiplication is commutative, both numbers have a certain role. So you either don't know the first one or you don't know the second one. So there's two types of division. And for this one, we can discover them by using the card sort. Okay, we call it a card sort where you just compare examples on cards, but we didn't make cards because they're just on a picture. So go ahead and pull up your picture. So we got that. So we have 17 people. So we're gonna just go ahead and throw up some breakout rooms. I'm gonna do 4, automatically throw you into 4 breakout rooms. Let's do, okay, so go ahead and join your breakout room for about 5 minutes. Talk about the card sort with your group. And sort them into 2 types. Kenna, can you hear me? Kenna, are you there?
Hey, Dr. B,
Yeah.
I'm on my phone, so I only saw briefly your chat. I can't figure out how to bring it back up. Will you tell me again what we're doing?
That's fine. So there's a picture that's on today's row in the course calendar on called card sort. And so it's just a sample of 6 division word problems. And you have to kind of look at the structure of the word problems and see 2 categories of types of problems. Okay, thinking about the groups, the number of groups and how many are in each group from multiplication. Okay, so they're going to ask you similar types of questions, but the setup is going to be similar between 3 of them, and the other 3 are going to have a similar setup as well.
Gotcha.
So you can sort
Thank
them
you.
out. I don't know if you guys can or not, but I'm trying this out as an experiment.
Sounds good. Thank you. That helps.
Okay. Yeah. So we can go check on other rooms, make sure they don't have any questions to start.
Okay, so have you guys had a chance to look at all the
It works. It's just like a black screen.
Weird.
Oh, maybe there we go. It's coming up now.
You got it?
Yeah.
Okay, did you guys find the card sort? The little sample problems?
Yes.
Okay.
Just giving Tracy a second to look them over because she just got them pulled up.
Okay, yeah. Good, good.
Yeah, I was
Right.
having some technical
Oh.
difficulties.
Oh, they happen. I can tell you. All right, so I'll check to make sure that the other rooms have access to them. Everybody here found the cards?
Yeah, we got them pulled up. We were just confused on if there was 2 or 3 types.
There's 2 types of division problems, but there's 3 examples of each type in this card sort set. Okay, so you have 6 cards, and there's 3 examples of the 2 types of division problems.
Okay.
Yeah.
Okay,
So just
and
kind of read through them and see if you can find any structure of them that are similar.
Okay.
So this is an experiment, so I'm not sure if you guys can get very far, but we'll see. We'll try it for a few minutes.
okay.
All right, so I'm going to check with the last breakout room.
All right,
Yeah,
thank you.
Be round. All right, do you guys have all the cards? The little example?
Yes,
Up? Okay, good.
I think so.
All right, so you're sorting the 6 cards into 2 groups of 3
Yeah.
based off division. So you're going to divide the cards up into 2 groups of 3.
Yep, I think we figured it out.
Okay, so tell me what you have so far.
So we thought A, B, and D are one group, and then C, E, and F are the second group.
Okay, and what made you decide for those groups? What characteristics of those problems stood out to you?
Tony actually pointed out that A, B, and D, you're deciding how many is in each. Oh, I'm gonna say this all wrong because I don't know what I'm talking about. And then like the other ones are, I don't know. No, I don't know what I'm talking about. Somebody else
got
talk.
it pretty close.
Yeah.
I said that A, B, and D all started out with like a total, and then they took like groups of it. So like first one is you had a total of 30 sticks, and you took 3 groups of it, and it's asking how much are in each group. Whereas in like C, F, and E, they're all saying you had this much, and you have this much in each group. How many groups are there?
Okay.
Yeah.
Yeah. See, Tony, that was good description, and Haley, that was good attempt to describe what he said. So it's
He made
important
sense
to,
when he said it. I just didn't know how to repeat it.
yeah, because this is actually a tricky part, and it takes a little bit to get down. Yeah, so go ahead and try talking about like an example from each and saying, you know, pulling out of the context a little bit, and you're looking at just the numbers or the situation, well, like the setup, where you do have a total, and in half of them you don't know how many are in each group, and the other half you don't know how many are how many groups there are. Okay, so remember that the multiplication problem is number of groups and number in each group. So groups of objects. Some of them you don't know the number of groups. Some you don't know the number of objects in each group.
Okay. So you
So
want
that's
us to
great.
go through and like separate or like put it into an equation kind of thing?
Yeah, that'd be a good exercise too. If you want to do the equation thing, I'm going to talk about that next. As a class,
Okay.
we'll do that too. So you can go ahead and get started on that.
Okay.
Okay, good work, everyone. Okay, did you guys get the groups? A couple of categories?
I think so.
Okay, so tell me what you got.
So we were thinking A, B, and C were all very similar in the same category, and then D, E, and F were in the second one.
Okay, so what's similar about A, B, and C?
Okay, I guess I'll talk. We were saying like A, B, and C, that they were all asking kind of things in a bundling type way, whereas D, E, and F were asking more like how to group it. So like how much for a child, how much in a payment, that type of thing.
Okay. There is a difference in how they're grouping things with B and C. So B has the total, and they're putting into boxes of 6. So they're taking 6 from the total, put in a box. Taking 6 from the total again, putting in a box. Okay, that's how they would do that one. Okay, hold on. 5 each. How many bundles were there? Okay, nope, sorry. It's going to be A and B. So yeah, B and C are the same. You're right, because Mr. Lin is taking books and putting in 5 books, bundled, done. 5 books, bundled, done. That's the same thing as B. In A, there's 30 sticks, but there's going to be 3 equal bundles. So he's going to take the sticks and he's going to put one in each section, and then kind of like dealing. He's dealing out the sticks to each bundle. Okay, so that's the difference. So A and B are different. B is like C. Okay, so that's the kind of grouping that we're looking at. All right, so let me go back to another group. You guys can think about that a little bit more, about the grouping type of things.
Okay, thanks, Dr. B.
You're welcome. All right, come back to you guys, because I wanted to double check your letters again. Which ones were like each other?
A, B, D, and C, E, F.
Okay, so A and B are actually different in the way you guys are talking about that.
Okay.
So in A, you have 30 sticks, but you can put them into 3 groups. You know the number of groups, but you don't know how many there are.
Okay.
In each group. And B, you know the size of each group, or how many are in each group, but you don't know how many groups there are. So in A, you know the number of groups, and B, you don't know the number of groups.
I would say the problem makes it sound like there's 6 boxes, but I guess into boxes is 6, meaning there's 6 balls in each box. Okay, that makes more sense.
Yeah, okay. I can see where that could get a little bit tricky. So I missed it the first time because, and then I was going to another group and we talked about it a little bit deeper. So, but the approach, Tony, that you had was correct. To look at the number of groups and the number in each group. Okay, so let me go to another one.
And A and D match, right?
A and D. Let's see.
Yeah. Because we had A,
Yes.
B, and D, but so A and D. So we just need to figure out the other one.
So A and D do match because you have children are the same as the bundles. Okay?
Yeah.
You have this number of groups, and you're trying to see how many fit into each one. So how many children get balloons and how many sticks fit into the 3 groups, 3 bundles. That's how they're similar, yeah. Good.
Okay.
So early childhood education, I think they're fun.
Yeah.
Hey, checking in with this group. Do you guys have your categories? Which cards go with which type of division?
Yes, sir.
Okay, so which one, what'd you guys find out? Which cards go with which type of division?
So did you tell us which type of division, like we have them grouped into ones that are similar. Did you tell us what the different types of division?
I haven't yet.
Okay.
What you do is like, we're kind of developing a need for a name for these types of divisions.
Okay.
So
We do have them grouped.
yes, tell us about your groups.
We have A, B, and D that were similar to where you have like a total and then you're trying to figure out, I believe it's the dividend. Am I wrong? Maybe I'm
Well,
saying
the
that wrong.
dividend is the total.
Okay. Sorry, I am saying it wrong. And then we had C, E, and F together.
Okay. All right. So A and B are actually different types of division.
Okay.
All right, so you guys are on the right track, but let's go ahead and adjust and double check to make sure that the structure of the problem is the same. Okay, so you're looking for what's going on in the problem. We each start with our totals, of course. So in A, there's 30 sticks, and B, there's 24 balls. Now the sticks in A have 3 equal bundles that they need to put them in, or 3 groups. So he kind of deals them out, like pretending like there's passing them out to 1 to each bundle, and then he does that until all the sticks are gone. So he knows how many groups there are. He doesn't know how many are going to be in each group. For B, 24 balls are packed into boxes of 6. So you take the 24 and you take off 6 of them, put them in a box. You take off 6 more, you put them into another box, and so on. And so in that question, we do know the total. We know how many are in each group, but we don't know how many groups there are. Okay. And so those are the 2 types of problems that we're looking at.
So is it A, D, and E?
So A and D are the same, yes. And E has you're taking $96 and you're dividing it up into 8 meters. Right. So did you know how many each meter costs? Yes. So A, D, and E are the same, and B, C, and F are the same.
That makes sense.
Okay. Great. So we're going to go ahead and come back together as a class. Okay, let's see, 10 seconds. A couple more people back in here. Okay. All right, welcome back, everyone. We have 2 types of division problems. And what letters did you guys sort the cards into, or groups into?
So our group,
Each other. Yeah.
so our group did A, D, and E,
Mm-hmm.
and B, C, and F, and we arranged A, D, and E because it was how many objects go into each bundle, and then
Yep.
B, C, and F was how many bundles is there.
Great. So great summary. All right. So I think well, as we were introducing these two types of division, it's sometimes you can get mixed up a little bit on which one was which. Okay. So it depends on the structure, and I'm going to go ahead and share my iPad. And we'll continue this discussion here, these thoughts. Now, in the two types of division are based off of the structure of the multiplication problem because it's the inverse of division, where we don't know the number groups or the number in each group. Okay, so I'm going to use my example of something times 8 equals 56, or 8 times something equals 56. In the first case, this what part we don't know is the first number in the multiplication problem, which has the role of number of groups. Okay. So we don't know the number of groups, but we do know the number in each group. That's like the division 24 balls and putting them into boxes of 6 each, okay? We don't know how many boxes there are or how many groups it will have, but we know that there's going to be 6 in each group. This type of division is called measurement division. Because you're measuring out groups of objects and putting them into their bundles. Okay? Because you're doing that, it's also thought of as repeated subtraction. Okay, so I have my 24 balls. I'm taking them off 6 at a time. Minus 6, minus 6, minus 6 until I'm done. Okay. So we can start out, just like repeated addition for multiplication, we can start out introducing division this way, but it will kind of come into a little bit of trouble when we get to fractions. But we study fraction division only from one perspective in this course, but you can if you want to see from more. But it's tricky. The 56 here is going to be your total again. Now, the 8 in here, in the second type of division, is the number of groups. We know the number of groups in this type of division, but we don't know how many are in each group. Okay. This is like the guy that's putting bundles of sticks. He knows he wants only 3 bundles. He knows the number of groups he has. So he just deals out the sticks to each bundle so that he can just take 3, and that's it. This one's called partitive division. And I like to think of this as dealing. Okay, dealing meaning like we're having a stack of cards and we want to deal out the cards to 5 players, you know. So you're dividing the cards to 5 players, among 5 players. So you're going to take, you know the number of groups you have and you just want to see how many are each group, so you give each of the players 1 by 1 a card. Or I take my 3 bundles of sticks. I know that there's going to be, take my 30 total sticks and put them into each group 1 by 1. Okay. So those are the 2 types of division. So let's talk a little bit more about measurement division to start. In this section, we're going to just show models or representations of division. Okay? So what I want you guys to do is come up with your own word problem and write it down in your notebooks. For division, measurement division, word problem. So here's an example. I have 28 candies. To put into bags. Each bag holds 4 candies. How many bags do I need? So there's my word problem. So what I'm going to do is I'm going to model this with first a bar model. Okay, and you guys can model yours as well. And the setup will be the same, but you'll have different numbers in different situations. But remember, this is the measurement division. It's repeated subtraction. I'm going to take all my candies in a bundle. I'm going to separate out 4 and throw them in a bag. 4, throw them into a bag. Okay? And I do that until I run out of candy. And 28 divided by 4 is an even number. So we're going to just kind of work with that for a little bit. Nice setup. So a bar model is I draw a bar for my total. Okay, there's my 28 candies. I'm going to start repeatedly subtracting them off. I take off one amount of 4 for one bag, another one, but I don't know how many bags I'm going to need. So I don't know how many of these boxes to draw. So what they do in the book is they do an ellipsis, which is however many you need. They put the question mark in the middle of this bar, and they do another ellipsis after it. Okay? So it's just however many I need to take off. This type of notation or drawing for bar model we haven't seen quite yet, but this is how they model the measurement division problems. And you can shade in here if you want. So there's the bar model. Go ahead and model yours with the bar model. Okay, so we have our total here, the dividend. This is our divisor, and we don't know what our quotient is. Okay. That's how those are the basic, no matter what division problem you have, you'll have those 3 numbers that you don't know the quotient. Okay, so we do have to move on. So you can bar model. The next type of model is a set model. These are types of models that we've studied throughout the other operations. Set model. A set model means I have the objects. I can do circles like marbles or anything like that. So I'm going to model 12 divided by 4. I have, let's say that I have 12 candies and that 4 go into each bag. So I'm going to model all my 12 candies here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to group them so they have one bag. These 4 go into a bag. These 4 go into a bag. And these 4 go into a bag. Okay. And then we're done. We have 4 groups or 4 bags. Nope, sorry, that's 3. Like something didn't look right. Okay, I have 3 groups when I do that. That's a set model. You can also have an array model. Arrays are, again, are a collection of objects formed into rows and columns. Now, I'm going to do an array model example. 10 divided by 5. I have 10 candies, and I want to put them, and each bag gets 5 candies. Okay. So there's one bag for 5 candies, but I don't know how many bags I'll need. So I can do this right here and put a question mark. And so when I'm done with this problem, I know that I'll have this many candies. Okay. I'll have 2 groups with 5 in each. And here I have one, I don't know how many groups, so question mark groups. Wait, sorry. Yeah. 5 in each. And that's an array. The next one is, the last one is area model. Area models come in handy because we find the area of things a lot, rectangles. For example, okay. So the area model is where let's say I do know the total area, but I don't know one of the dimensions of my rectangle. So here's my rectangle. I know that this length right here is 6. This one I don't know. But if I know the area was 18, then that means I can deduce what, or find out what the dimension is that I don't know. That's gonna be 3. Okay. So those are representations of measurement division. Measurement division, we don't know how many groups, but we know how many there are in each group. Measurement is repeated subtraction. They just keep taking off groups from the total and then keeping track of those. So this next one is partitive division. And in partitive division, we want you to come up with your own word problem. Partitive division is also thought of as dealing. Okay, so I know how many groups I have, but I don't know how many are in each group. So I need to deal them out, whether it be cards or sticks or whatever. Here's an example word problem that I came up with. I plan to run 8 miles. In the next 4 days. How many miles should I run each day? So I'm going to separate my 8 miles in 4 days. So I put 1 mile on each day, and I notice that I'll get 2 miles for each day. Now the set model, or the bar model, let's start here. I want to model your problem according to your numbers for your bar. And it looks similar to the other one. But I'm going to do 4 days is what I'm dividing my 8 miles into. So here's my total. That's the total I put on top. I'm going to divide them up into 8 days. So I actually modeled this with 8 days. So I divide it up into 8 pieces where I'm dividing the half into half and each of those fourths into half. Oh, sorry, 4 days, sorry. Let's stop there. And so each of those is 1 day. I don't know how many miles I'm going to do for those days. Okay, so that's that type of bar. I don't know if you want to do that or not, but let's see here. Go ahead and model yours as you do this. Model yours. Let's go ahead and do a set model for this one. Remember that this is dealing. I have my total. I know that the number of groups I have. I don't know how many go in there. We can do 12 marbles into 4 bins. 4 bins. And pick my 12 marbles here. And the set model has me do 4 bins. Okay? And I like these a lot because they can draw lots of crazy arrows. But you don't have to draw so many arrows if you don't want to. Okay? But I like to. So I'm going to take each one of these. I have 4 colors here. I'm going to the 4 bins. So this one's my blue bin. This will be my green bin, my yellow bin, my red bin. Okay. So I'm going to take this first ball and put it into the blue bin. Then I'm going to put the second one here in the green bin. Oh, these are marbles. And these all go to their separate bins. They're earmarked for these color bins. So I keep doing it. So I'm dealing all of these out here. I keep just taking each one and putting it, putting it into the bin. Let's go straight around. Okay. So this is a set model of division, this type of division. Okay. So that means that we have 3 going into each bin. Okay, so our array model, we have 10 things, and we don't know how many groups there are. Right? No, we don't know how many are in each group. We know that there's 2 groups. So I'm going to take my rows of circles. I know that there's 2 rows, but I don't know how many are in each column. Okay. We keep the same setup as before. I know that once I have these 2 groups, I know that there's going to be 5 in each group. Okay. So that's an array model. The last one is area model. (18 divided by 2). Okay, so the area model. You just pick one of the dimensions. The other one, in the other version, I knew what the top dimension was, but in this one I don't. So we're going to pretend that that's going to be the unknown number. This is going to be 2. And then the area is 18 inside there. But I know that when I finish my division problem, that's going to be 9. Okay, what times 2 is equal to 18. Okay, so that's what I'm thinking to get this number. All right. That's kind of what we're thinking as we do the division as the inverse. How is the division the multiplicative inverse? And since we're kind of low on time, we're just gonna have to like kind of answer it here. Okay, so for example, and I mentioned it just now with that yellow comment. To find the answer to 36 divided by 9, we think what do I multiply by 9? What times 9 is 36? So in general, we think what times the divisor? What times the divisor gives the total? Or the dividend? That's where we're thinking for multiplicative inverse. When you have, now we know that what division is the opposite of multiplication, we can do 4-fact families, just like we did with subtraction and addition. So to start your 4-fact family, you think of a multiplication fact. Like 4 times 6. Okay. And we use the commutative property to find the next one. To find fact number 2 of the 4-fact family, we use the commutative property, just like with addition. When we use the commutative property, we get 6 times 4 is equal to 24. The third fact of the 4-fact family is we use the multiplicative inverse of number 1. Okay. And that means that we say that 24 divided by 4 is equal to 6. The fourth fact is you use the multiplicative inverse on the second one. Which means that we say 24 divided by 6 equals 4. Okay. Any questions on 4-fact families? Pretty straightforward. They help you learn multiplication and division facts. So they're very useful in the elementary curriculum. All right. The last part is a little thought about dividing by 0. What would dividing by 0 mean from, well, any perspective?
Is it that it's like, it doesn't make sense, so it's undefined?
Yeah, dividing by 0 is undefined.
If
Or
you
there's
ask
no solution.
Siri has a really good answer to that question, and it's really funny.
Okay, can you do Siri for us?
I can't because I'm on my phone, but
You're already on your phone.
yeah.
What is 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
Do you guys hear that?
That was a good one.
So, yeah. So what kind of perspective was she using? I lost it though. She's taking 0. Yeah. So what do you guys think? What perspective was she using?
You can't divide what you don't have.
So
Sorry, Camille.
no worries. Were you done?
Yes.
Okay, so I was just gonna say like anything multiplied by 0 is 0. So anything that is divided by 0 would be 0, right? Or itself. I don't know.
Those are good questions. So let's take like the measurement perspective. I have a certain number of candies, okay? And I'm going to put 0 in each bag. So I have a candy. So if you guys need to go, that's okay. We're at time, but this will take a couple more minutes, and then you can look at the video if you want to see it later. So I have a candies. Let's use numbers here, just for fun. I have 24 candies, and I put 0 in each bag. How many bags do I need?
0.
Okay. Well, see, you don't even get that far because you can't put 0 into anything. Because you're trying to take your candies and you're just taking nothing and trying to put it into a bag. So it doesn't even get to 1 bag or 0 bags. Okay. Let's think about partitive. I have 24 candies, and I'm going to give them to 0 people. Okay. The question is how many does each person get? No, how many? Yeah. Okay. So it doesn't make sense there either. What Camille had alluded to is the last part here. That if I have like some sort of number trying to divide by 0 equals something, looking at the inverse form where I have something times 0 equals a number, or 0 times something is a number? Can 0 times something equal a number? Okay. So that's why we call it undefined. Or there's no solution. Because all of our 0 facts end with 0. 0 times 1 is 0. 0 times 2 is 0. 0 times 3 is 0. Okay? So if we take a number divided by 0, it doesn't have any answer. Because you can't multiply something by 0 and get a number. Okay? Okay, so that's why it doesn't work. You can see with the situation in real life that it doesn't make sense. Okay, you just don't get anywhere. Okay, so that's all I had for today. And let me know if you guys have any questions.
Dr. B, could you go back to your tablet? I take screenshots so that I can look back on them for homework. Could I take a screenshot of the last?
I also post the screenshots to Canvas.
Yeah, just so I have it on my phone and on my laptop from your copy, if that makes sense.
Well, I do post my copy, but I will go back anyway and let you take screenshots if it will listen to me. Okay, so is that good? That last part? Did you get it?
Sorry, I couldn't unmute. I got it. Thank you so much.
Okay.
See you Friday.
Yep. Have a good day.
You too.